Hi everyone, I just wanted to go over the proofs one more time. This problem in front of us is problem number 3 in the activity that we did on Tuesday. And people did the odd numbers. This is number 3. I'll also be using the same diagram but different givens, and the proof actually I think the same given, but we're going to try to prove different angles also. So I'll be doing this problem and also problem 4, so problem 3 and 4. And if you refer to the worksheet that is attached to the announcement, you will see that all the problems are included with the steps. Problem 3 and 4 are very unique because we have 3 lines that are parallel to each other, but they only gave us J and K are parallel, and K and L are parallel. So if we decide to go to the route that to prove J and L are parallel, then to go through the angles we can, or we can just work with the given and derive angles from that without proving the lines are parallel. So I'll be actually doing 2 ways for that proof. And it's pretty good to actually start with 2 ways because I want you to understand when or which angles can you derive from each given, and what things you can or cannot write in the justification side in your 2-column proof. So I'll be doing 2 columns, the steps over here, and then the justifications over here. Okay, so we always start with the given. If they gave you something like parallel lines, in that case, you start with that, and it's very simple. You write that's a given. Now, from each given, I know they gave us 2 pairs of parallel lines. From each given, you have to derive something. So you have to actually conclude something. Notice that we want to go forward with our steps to reach angle 1 and angle 3. So from the lines J and K, we can pretty much ignore line L in that step because we're focusing on J and K. We can actually, from that given, we can conclude that angle 1 and angle 2 are corresponding angles, so they're congruent. Or we can also conclude angle 4 and angle 5. Now, we can conclude either pair, but which pair do I really care about? I care about angle 1 and angle 2, because I am going forward and I'm trying to reach angle 1 and angle 3 and prove them congruent. So if I pick 4 and 5, I'm pretty much not involving any of these angles that I'm trying to get to. So I'll pick angle 1 and angle 2 to work with based on the fact that they told me the lines are parallel. I am allowed to say that angle 1 and angle 2 are corresponding angles and therefore congruent. So I'll say that angle 1 is congruent to angle 2 because they're corresponding angles. And again, I can write corresponding because they told me the lines are parallel. If that was not a given, I'm not allowed to write that corresponding angles. I'm not allowed to write that step. But I can because the lines were given to me parallel. Alright, so the other step is to write the second given. And I'll try to make that look better. Line K and line L. So again, that's the second given, and from each given I have to conclude something. So if I'm focusing on line K and line L right here, pretty much in that step I will ignore line J because I'm focusing on K and L right now. So if I'm focusing on K and L, I can conclude either 2 and 3 congruent or 5 and 6 congruent. Both are correct, but which ones do I really care about? Again, I'm trying to reach angle 1 and angle 3 and prove them congruent. So if I pick 5 and 6, I'm not involving any of the angles that I will reach eventually. I am trying to reach those. So if I pick 5 and 6, they will not help me reach or complete my proof. So for that, I can pick 2 and 3, and those are the ones that I'll be choosing. And they are congruent because, again, they're corresponding angles. and in that case the transversal is pretty much that line. So corresponding angles, they're both on the same side of the transversal. Again, the transversal is that horizontal line right here, and they are on the same line. One of them is interior between the parallel lines, and one of them is exterior. So corresponding angles, just as a review, like angles 2 and 3. Okay, now for the transitive property, a lot of people don't know when to use it. That's a perfect way or a perfect example for you to understand what the transitive property is. The transitive property works when two things are being equal or congruent, and then a third thing is equal to one of those two that you started with. So pretty much you have angle 2 in common, and you have two congruency statements. Okay, so the transitive property works for equality or congruency only. So we have 1 congruent to 2, 2 is also congruent to 3. Again, you see 2 is in common between them. In that case, angle 1, I can say is congruent to 3 because those are the two different ones. Again, 2 is in common. So angle 1 is congruent to 3, and that's the transitive property. So again, from each given, I have to conclude something, and after I conclude that thing, I write the other given, conclude something, and then I have to analyze the previous steps and see if I can reach what I'm trying to prove from these steps and write a reason. So I can reach that angle 1 and angle 3 are congruent because that's the transitive property. Now, a lot of people get confused between these kind of statements and when we have two angles supplementary, and then two angles supplementary in the second step, and then we have one in common. But for supplementary angles, not congruency, supplementary angles. For supplementary angles, I can say that angle 1 is congruent to 3 if they were both supplementary with 2, but the reason will not be the transitive property. The reason will be the congruent supplement theorem. So again, the transitive property only works for congruency or equality statements. So this is a perfect example of that. Now, the same problem I can prove differently. So from the 3-3 lesson that we did on Tuesday as well, we proved that if two lines are parallel and a third line is parallel to one of these lines, then I can conclude that all three lines are parallel, pretty much. So I'll be doing that same problem in a different way. So with the same problem, the same givens and the same, let me erase that line, I don't know why I did that. Anyway, so with the same given and the same thing that we're trying to prove, we can actually get to the same result, that angle 1 is congruent to angle 3, but in a different way. So I'll be doing also two-column proof, and I will be using reasons from lesson 3-3. I remember the 3 theorems that we created examples for. So you may refer to that worksheet to help you if needed. So I'll be writing the givens. Line J is parallel to line K, and line K is parallel to line L, and those two are givens, and I will not be concluding angles from those because my goal here is to actually conclude parallel lines. So I know that K is a line in common, J is parallel to K, also L is parallel to K, and from that I can conclude that J is parallel to L, and that's one of the theorems that we covered in lesson 3-3. So J is parallel to L, and remember when I went over that lesson, I said, alright, well, the only thing that you have to know is you have to be able to write that in a sentence so that you can use the lesson or the theorems and they will be counted correct. So you have to justify that. And pretty much if we remember the theorem, it tells us that if two lines are parallel to the same line, then they are parallel to each other. And from that conclusion that J is parallel to L, if we pretty much ignore line K in the middle, if we take that out, I'll try to see if I can take that out so that it's clear for you. If we take the middle line out, it will be obvious that angle 1 and angle 3 are corresponding angles. So we can say that angle 1 and angle 3 are congruent because they are corresponding, only because we proved that the lines are parallel. So we can't use corresponding angles as a reason unless the lines are already parallel. So if the lines are parallel, I don't know why this is a double F. If the lines are parallel, then I can say that the angles are congruent, since the lines are parallel because they're corresponding angles. So for this problem, we focused pretty much on corresponding angles,